Section 5.7 Inverse Trigonometry Functions Integration. We have seen in section 5.6 the formula for the derivative of 6 inverse trig functions. In this section, we're going to learn about integrations that involve inverse trig functions. Let u be a differentiable function of x and a bigger than 0. So u is an expression of x. And these are general formulas. The integral du over square root of a squared minus u squared equal arcsine of u over a plus c. And we have two other integrals involving inverse trig functions. Then you might want to ask the question, why are there only 3 integrals and not 6, since we do have 6 inverse trig functions? Now, if you take a look back in section 5.6 and compare the formula right here, derivative of arcsine and derivative of arccosine, the expression right here is almost exactly the same except just the sign difference. Same thing can be said about arctangent and arccotangent, arcsecant and arccosecant. Therefore, we only need formula for 3 inverse trig functions, okay, because the cofunction are only -1 factor difference, and we know how to handle the constant -1. So let's take a look at example number 1. How do we apply these formulas to find the integral dx over square root of 1 minus 4x squared? The first thing to do is to compare this integral with the 3 formula up here. And we notice this formula is similar to number 1. In that case, we just need to identify what a squared is and what u squared is in order to apply the formula. So a is the constant, and in this case we have 1, so it's a equals 1, and u squared is behind the negative sign, so we have 4x squared behind the negative sign. And our job is to identify u and a, because those are the expression we will have in the antiderivative. So we get a equals 1, square root of 1 is 1, and square root of both sides we get u equals 2x. So we can transform our integral by using u sub. And we do need to, because of the u sub, we do need to find du. Since u equals 2x, du is twice dx. So dx equals 1/2 du. We can replace dx right here by 1/2 du. Okay, divided by square root of 1. 1 is still 1, that is our a, or 1 squared, minus 4x squared became u squared. So we can apply the formula right here. And the formula tells us that integral is just arcsine of u over a. And our u is 2x right here. So it's 2x over a equals 1. So this is the antiderivative. Our answer for example number 1. Now let's take a look at example number 2. We need to find the integral. 12 dx divided by 1 plus 9x squared. Again, we have to compare that with the formula that we have. We notice it looks like number 2. Okay, so we have to again identify a squared and u squared. And you don't need to worry about this number 12 because we can always factor it out. So our a squared will be the constant 1 and our u squared will be 9x squared. So that will give us a equals 1 and u equals 3x. Then our du equal 3 dx. But right now we have 12 dx. So 12 dx, multiply both sides of this equation by 4, we get 4 du. Now it's time to apply u sub. On the top, we replace the 12 dx by 4 du. We always factor out the constant in front of the integral sign. In the bottom, we have 1 plus our u squared, or you want to say 1 squared plus u squared. So according to the formula right here, we get 1 over a. Okay, so our antiderivative is 4 times 1 over a. Since a equals 1, it's just 1. Arc tangent of u, which is 3x over a is 1. Let's see. So that is our answer for example number 2. Now let's take a look at example number 3. You might want to say, wait a minute, x minus 3 quantity square, I don't know how to handle this one. Well, if you go back and take a look at the formula, u is an expression of x. So it doesn't matter, it can be 4x squared, 9x squared, or in this case, x minus 3 quantity square. That will still be our u. Now we notice there's no square root, so we know it has to be the second formula. And we just need to identify our a and u. So let me copy down the second formula right here, so we can all see. Integral du over a squared plus u squared equals 1 over a arc tangent of u over a plus c. So we compare turn by turn. We have 4 and a squared. So obviously a squared equals 4. So a equals 2. Our u squared is the expression behind the plus sign. So it's x minus 3 squared. Then our u is just x minus 3. It will be okay to replace this. Okay, so replace the bottom by a squared or 2 squared plus u squared. So compare these two. They look similar. Then on the top, we need to find out what is the expression for dx. Well, we take the derivative on both sides of the u expression. So du equals, derivative of x is just 1. And this is 0. So du equals dx. So we can replace dx by du. Now compare this with our formula. We just directly plug in a and u. So a in our case is 2. So a is 2. Arc tangent of u is x minus 3 divided by a, 2 plus c. So this is the antiderivative